Hey, welcome to today's lesson where we're going to talk about how you can write the equation of a line. And you remember from algebra last year that we have this form. It's called slope-intercept form, where m is the slope and b is what we call the y-intercept, where that graph hits the y-axis. And this should be a review for most of you, but it's a nice review to take as we start to take a look at some geometric shapes that are put on the coordinate plane instead of floating around in space. So let's take a look and let's just jump right in and do a problem together. Let's say in our very first scenario we need to write the equation of a line that has a slope of 3. So we know the slope, so it looks like I'm using a green pen for slope, but it passes through the point 2, -5. Now 2, -5, this is not the y-intercept. This is just a point that the graph passes through. So here we go. We have our generic form for the equation of a line. And what do I know? Well, I know the slope is 3, so I'm going to put a 3 there. I don't know the y-intercept. That is a mystery to us, so I'm going to call that b, because that's the point on the y-axis through which this graph passes. But I do know an x value that this line goes through. I know that this line passes through an x value of 2, so I could put a 2 right in there for x. I also know when x is 2, the y value is -5. So what that means is I could put a -5 in for the y value. And so what I'm doing is I'm using this generic equation and I'm plugging in the things I do know. I did know the slope was 3. I did have an x value of 2 and a corresponding y value of -5. And now this just becomes a simple algebra problem. -5 equals 6 plus b. And solving this, we get -11 is our value for b. So now I can go back to my generic equation and say, okay, I know generically any y is equal to the slope. Now we knew the slope was 3 times any x plus b. And since b is -11, I'll just write -11. So generically, we have y equals mx plus b. We plugged in a very specific x and its corresponding y, and that helped us find the b. But when we go to write the actual equation, we want to talk about any x and any y, not a specific x and y, but just the generic x and y. So this would be a good time for you to pause the video and see if you could do number 2 by yourself. So why don't you try that? Why don't you pause the video and try number 2, and then unpause and we'll talk. Okay, welcome back. So number 2 is a lot like number 1 was. We have a given slope, so I can put that -2/3 right there for x. We don't know the b. We don't know the y-intercept, so I'm going to have a plus b hanging on here at the end. But what we do know is we do have, whoops, wrong pen. We do have a very specific x of 6 and a very specific y of 1. So now we can do some math. Now if you want to use a calculator, that's fine, but you also can just do this by hand. 3 goes into 3 once, and 3 goes into 6 twice. So this becomes -4 over 1, or just -4. And so we get 5 is equal to b. And remember, this is our y-intercept. So we have the slope, we have the y-intercept, so we'll go back and use our generic y equals -2/3 times our generic x plus b. b is 5. Okay, so those are one type of problems where we're given the slope and we're given a point. But that's not how all problems are. Sometimes we're given 2 points like this. And when you're given 2 points like this, well, it's a lot like the previous problem. It's just we have a little bit of work to do. And in this case, the work we have to do is we have to find the slope. So this was what we did the last time we met together. Remember, you can find the slope by taking any y, like this, 5, minus the other y, which is negative 3, over the corresponding x, 2, minus the other corresponding x, 6. And we get 8 over, or divided by, negative 4, which is negative 2. So with a little bit of work, we were able to get the slope of negative 2. Now, we still don't know what the y-intercept is, so hanging on to the end of this problem is that plus b. But we do have an x value. As a matter of fact, we have two x values. And it doesn't matter which x value you choose. You could choose either one. Maybe I'll just choose this one right here. So if I put a 2 in for x, and we could use either one, what y value do I use? Well, you have to pick the y that corresponds with the x that you used. So since we chose 2 as our x, our corresponding y is 5. And now we just work through the math. 5 equals negative 4 plus b. So 9 is our value for b. And so we found our y-intercept. So when we go to write this equation, we are going to use our generic y equals our slope, which we found. We weren't given the slope. We found it to be negative 2 times our generic x plus 9. That is our y-intercept. Okay, so you've seen how to do some problems where we give you the slope and a point, and now you've seen how you do some problems where you're given 2 points. Why don't you go ahead and see if you can do a new one now. This one, number 4, a little tricky, but I think some of you can figure it out. So I'll be quiet while you pause the video, try it, and then come back and we'll see how you did. Okay, welcome back. This time, the difference is we have a point, just like we've always had, but I'm telling you it's parallel to this equation. Now, what do we know about parallel lines? Well, we know that parallel lines have the same slope. So what I need to do from this is I need the slope. And right now, it's not written in a way that reveals what the slope is. What I need to do is I need to take that 2x minus 6y equals 9, and I need to make it look like that. So I've got to get it so the y is all by itself. So maybe the first thing I'm going to do is subtract 2x, because I want the y all by itself. And that gives me negative 6y equals negative 2x plus 9. Now, again, I'm trying to find out what the slope is, and to do that, I need the y all by itself. So I've got to divide both sides by negative 6. And when I divide by negative 6, I get y equals, now look at this, a negative divided by a negative is a positive, and 2 over 6 reduces down to 1 over 3. So y equals 1/3 x, and then over here, a positive divided by a negative is a negative. And when I reduce this down, 9 over 6 is, well, actually, I think this is okay for us right now, isn't it? Because what was the only thing we wanted out of this equation? Well, the only thing we wanted out of this equation was the slope, and that is the slope right there. So I know that the slope is 1/3. And so in order to find the slope, we rewrote this equation as y equals mx plus b. We got the slope that we wanted, and now we need a parallel slope. Well, remember, parallel lines have the same slope, so 1/3 is going to be the slope I want. So that's the slope I'm going to put in my new equation. But what I need in my new equation is I need to know what that y-intercept is, and I don't have that. So I'm going to have to do some work. That's where I need to take this x, 9, and this y, 2, and plug them into that equation, because this y-intercept over here worked for this equation. This is a totally different equation over here. So doing our math, and again, feel free to use a calculator or use those skills you learned in middle school. 2 equals 3 plus b, so our b is -1. So we have our y-intercept and we have our slope. So my new equation, y equals the slope we want, which is 1/3 x, and our brand new y-intercept -1. Okay, let's take a look at this one. Now this next one, number 5, is a lot like number 4, except I see we have a new word, perpendicular. So just like number 4, we need to get the slope out of that equation. You always have to get the slope. And the way it's written, well, it's not telling me what the slope is. So I need to take that 2x minus 5y equals 12, and I need to get the y all by itself. So I might start out by subtracting 2x from both sides. And that gets me -5y equals -2x plus 12. Now the y is not all by itself. It needs to be all alone. So I'm going to divide both sides by -5. And that gets the y all by itself. And we get y equals. Now a negative divided by a negative is a positive. And 2 divided by 5, well, that's just 2 divided by 5. It's just 2/5 x. And over here, who cares? We don't care what the y-intercept of this line is. All I want out of this line is the slope. And I can see the slope is 2/5. But actually, I want the perpendicular slope. So the perpendicular slope is going to be the opposite, not positive, but negative, reciprocal, which means we're going to put the 5 in the top and the 2 in the bottom. So now that is my slope. And after all that work, I can put a -5/2 here. But the sad news is we don't know what the b is, the y-intercept. Because the y-intercept of a line with this slope through this point is most likely different than the y-intercept of this line. So let's put in -4 for x, and let's put in a 1 for y, and let's see what the math tells us. So 1 equals, now 2 goes into -4, -2 times. Again, you can use a calculator for this. -5 times -2 is 10 plus b. So it looks like my b is -9. That is the y-intercept that I want to use. So when I write the equation of this line, this is my slope, this is my y-intercept, and I get y equals -5/2 x minus 9. And one last problem here. Let's skip number 6 because it looks like we're running low on time. Number 7, this time I want it parallel to the line at the right. And when I see that word parallel, it tells me I need the slope. So let's look at this line at the right. It's kind of nice to have a graph because I can count the slope as the rise, which it looks like I went up 2. So my rise is 2. And my run, 1, 2, 3, 4, is to the right 4. So it looks like my slope is a half. So I can put 1/2 in for my slope. But I need it to pass through this point. So I don't know what my y-intercept is going to be. It's a different y-intercept than this is. And by the way, this y-intercept is some fraction. But I can put in my -8 for x, and I can put in my 3 for y. And solving this, I get 3 equals, well, 2 goes into -8, -4 times, -4 plus b. So 7 is my y-intercept. So I know I want my slope to be a half, so 1/2. And I know I want my y-intercept to be 7. So today was a